Module 9, Chapter 7.3, the Reduced Row Echelon Method. This method uses matrices to solve systems of equations. Now, a matrix is a rectangular array of numbers enclosed by brackets. Each number in the array is an element or an entry. A matrix is named according to its size, the number of rows by a number of columns. So a 2 by 2 matrix would have 2 rows and 2 columns. So that row 1 would be 1, 4, row 2 would be 0, 4. Column 1 would be 1, 0, column 2 would be 4, 4. Matrix methods are suitable for calculator and computer solutions of large systems. We can convert a linear system into a matrix as shown. Notice if we write all of our equations in standard form, everything in the first column are x's, everything in the second column are y's, and everything in the third columns are z, and the fourth columns are your answers. So when we write it as a matrix, we just know because it's in the first column, these are the x coefficients. Because it's in the second column, these are your y coefficients, and so on. Now, this is called an augmented matrix, where each member of the array is called an element. The vertical line separates the coefficients of the variables from the constants. Now, the rows of an augmented matrix can be treated just like the equation of a linear system. So let's start with the basics. Write the augmented matrix for the system. Do not solve. So we look at that. We know there's 3 equations, so our matrix is going to have 3 rows. We know there are 3 variables. We've got an x, a y, and a z, and then we've also got a number column. So for the first equation, there'd be 1 for the x's, 1 for the y's. There are no z's, so we put a placeholder of 0 separated by our vertical line with an answer of 2. The second equation, there is no x, 2y, 1z with an answer of -4. Our third equation, there's 0x, 0y, 1z with a y value of 2. That is what we call an augmented matrix. Now, for any augmented matrix of a system of linear equations, the following row transformations will result in the matrix of an equivalent system. First, any 2 rows may be interchanged. So if we would like to switch row 1 and row 2, we can. Number 2, the elements of any row may be multiplied by a non-zero real number. So if we needed to multiply the whole row 2 by a 3, we could, and that would give us an equivalent matrix. And third, any row may be changed by adding to its elements a multiple of the corresponding elements of another row. What that means is to change row 3, we can add another multiple. We could add a multiple of another row to row 3. So, use matrix row transformations to transform each matrix. If the command is 5 times R1, that means we're going to multiply everything in row 1 by 5. That would give us -5. 5 times 4 would be 20. There's no command for the bottom row, so row 2 stays exactly the same. Okay, now the second command says 3 times row 1 plus row 2. Well, if we're adding a multiple of another row to row 2, just remember, then it's the new row 2 that's being changed. Okay, so when we come over here for our new matrix, row 1 does not change, row 3 does not change, we're only changing row 2. And the way it works is we're going to do 3 times each element in row 1 and add it to that element in row 2. So we're going to do 3 times 4 is 12. 12 plus 7 is 19. We're going to do 3 times 10 is 30. 30 plus 4 is 34. We're going to do 3 times 8 is 24. 24 plus 3 is 27. So that's the new matrix that's equivalent to the first matrix. Now, matrix row transformations are used to transform the augmented matrix of a system into one that is in echelon form. Now, echelon means triangular. The matrix of echelon form will have ones down the main diagonal. So everything starting up here will be a 1. And it will have zeros in the triangle underneath the main diagonal. Now, once you have the matrix in row echelon form, then we go back to equation form and then use the back substitution to find the solution set. So, for instance, if we started out with a set of equations and we wrote our matrix, and then we found echelon form, now we're ready to go back to equation form. This bottom equation means that z is equal to -2. The second equation, 0x and 0z, which means 1y, is equal to 9. Now the first equation says x plus y is equal to 8, but remember we just said right here that y was 9, so that means x plus 9 is equal to 8, which means x is equal to -1. So now we would know the 3 values for x, y, and z. Now another method for solving systems is the reduced row echelon method. And the difference in reduced row echelon and just plain row echelon is that in reduced row echelon, you also have zeros above the main diagonal. I know that says below, but you'll have it above the diagonal and below the diagonal. This eliminates the need for back substitution. So you want the ones below the ones along the diagonal, zeros above, zeros below. Okay, so it says solve the following using the reduced row echelon form method. First, we're going to transform the system into an augmented matrix. So if we do that, we get 1x, 1y, 1z, draw your line, 6. We get 2x's, 1y, 1z equals 5. And we get 3x plus 1y, -2z is equal to 10. So this would be the augmented matrix. Now, we want to get ones down the main diagonal. So we've got our 1 here. Now what we want to do is replace these two values with zeros. So remember how we changed the values of a row? We can add the multiple of another row to it. So what it amounts to is we're happy with row 1 for right now. Okay, we've got our 1. Now we want to get the zeros. So what we're going to do is we're going to say, hey, let's multiply -2 by row 1. Add it to row 2, and that would give us a 0. Okay? -2 times 1 is -2, plus 2 is 0, all the way across. -2 times 1 is -2. -2 plus 1 is -1. -2 times 1 is -2, plus 1, that would also be -1. -2 times 6 is -12, plus 5 would give us -7. That's good. That's what we wanted, that first 0. Now we're going to work on this 0. So we're going to use this 1 to get this. So we're going to do negative 3 times row 1 plus row 3, and that will give us the new row 3. So negative 3 times 1 is negative 3, plus 3 is 0. Negative 3 times 1 is negative 3, plus 1 would be negative 2. Negative 3 times 1 is negative 3, minus 2 would be negative 5. And negative 3 times 6 is negative 18, plus 10 would be negative 8. So that got our first column complete. Okay, next we need a 1 in the second row and second column. So we need a 1 right here. Well, remember the property number 2 that says we can multiply a whole row by some number? Well, we're going to multiply that whole row by negative 1, or you might think divide the whole row by negative 1. So we're going to do row 2 divided by negative 1. Okay, and that will give us a new row 2. So we get 1, 1, 1, 6, 0. Now negative 1 divided by negative 1 is 1. Negative 1 divided by negative 1 is 1. Negative 7 divided by negative 1 is 7. And then that third row has not changed yet. Okay. Now we want to get a 0 above and below that 1. So what we're going to do is we're going to use the 1 that we just found to change that one. So to get a new row 1, we're going to do negative 1 times row 2 plus row 1 will give us a new row 1. Okay, so what we would get is negative 1 times 0 is 0, plus 1 is 1. Negative 1 times 1 is negative 1, plus 1 is 0. Negative 1 times 1 is negative 1, plus 1 is 0. Negative 1 times this 7 would be negative 7, plus 6 would be negative 1. So that fixed our new row 1. Well, we're happy with row 2 because we've already got that 1 where we need it. Row 3. Well, we've got a negative 2, which means we could add a positive 2. So the way we get a positive 2 is we say 2 times row 2 plus row 3 will give us a new row 3. Okay, so 2 times 0 is 0. 0 plus 0 is 0. 2 times 1 is 2. 2 plus negative 2 is 0. That's what we wanted. 2 times 1 is 2. 2 plus a negative 5 is negative 3. All the way across. 2 times 7 is 14. 14 plus a negative 8 is 6. So now we've got column 1 done. We've got column 2 done. Okay, now we're up to this point right here. Now we need a 1 in the third row. So because that is a negative 3, so we've got row 3 divided by negative 3. Notice the first row does not change. The second row does not change. But the third row, 0 divided by negative 3 is 0, is 0. Negative 3 divided by negative 3 is 1. 6 divided by negative 3 is negative 2. Okay, that got our 1 where we wanted it to be. Now we want to get zeros above that. Well, we've already got it in the first row, so the first row is going to be good. The first row is 1, 0, 0, negative 1. The third row is actually good. 0, 0, 1, negative 2. So what we're going to do is we're going to use the 1 that we found in row 3 to change the 1 in row 2. So we're going to do negative 1 times row 3 plus row 2 will give us a new row 2. Okay, remember you always add back onto the row that you want to change. So negative 1 times 0 is 0, plus 0 is 0. Negative 1 times 0 is 0, plus 1 is 1. Negative 1 times 1 is negative 1, plus 1 is 0. Negative 1 times negative 2 is 2. 2 plus 7 is 9. Now, this is what we call reduced row echelon form. The matrix is equivalent to the system 1, 0, 0, negative 1, 0, 1, 0, 9, 0, 0, 1, negative 2, which says there's your z value, there's your y value, there's your x value, so we get x equals negative 1, y equals 9, and z equals negative 2. Now, we can do this on our graphing calculator without all of those steps. First thing we're going to do is enter our values into our calculator. You know, we may want to go back through and say, okay, what is the augmented matrix going to look like? 1x, 1y, 1z equals 6. 2x, 1y, 1z equals 5. 3x, 1y, negative 2z is equal to 10. So what we want to do is we want to get the augmented matrix into calculator form. So we are going to go matrix, which is down here, so we're going to go second matrix. The first thing we want to do is edit it. So we're going to slide to the right to edit, and we're going to choose enter to select matrix number A. Then we're going to go through and select the size. Well, this is 3 rows by 4 columns. So we're going to say 3 enter 4 enter. And notice that now it gives us a matrix of size 3 by 4. This little brace on the end means there's nothing back here. This little dash means there are more values over there. So we're going to start entering. Row 1, column 1 is this first entry right there. So we're going to say 1. Now you notice the cursor slides over. Row 1, column 2, which is 1. Row 1, column 3 is 1. Now, do you see how the calculator shifted over? So now we're on row 1, column 4, which is 6. Now it slid us all the way back. So we're going to enter 2, 1, 1, 5. And then we're going to enter the third row, 3, 1, negative 2, and 10. So when you get your matrix set up, what you need to do is make sure you go second quit. Okay? So you enter your values and then you do second quit. Now what you're going to do is you're going to go second matrix. This time you're going to slide over to math, and you are going to go all the way down until you see RREF, which is number B. You're going to select RREF, which stands for Reduced Row Echelon Form. And we want to find RREF of matrix A. Well, remember, that's in second matrix. We stored our stuff in matrix A, and we're always just going to use matrix A. And then when we press enter, it gives us the 1, 0, 0, negative 1, 0, 1, 0, 9, 0, 0, 1, negative 2. Look at the last column because those are our answer columns, which says x is negative 1, y equals 9, and z equals negative 2, exactly like what we've been doing pencil paper method. Okay, you want to do another one on your calculator? So we're going to set up our calculator. We're going to go second matrix, then we're going to slide over to edit. Then we're going to select option number 1. The size of this matrix is still 3 by 4. So we're just going to go 3 by 4, enter. Now we're going to pull off the numbers in our matrix. Well, that would be 1, 2, 1, 30, 3, 2, 2, 56, 2, 3, 1, 44. And now we're going to enter these values straight into our calculator. 1, 2, 1, 30. Row 2, 3, 2, 2, 56. Row 3, 2, 3, 1, 44. Now make sure that you go second quit, or it's going to do weird stuff to your matrix. Now we're going to go back and go second matrix. This time we're going to slide to math, and then we're going to go all the way down to number B, which is REF. We're going to select a number B. We're going to select matrix A, so we go second matrix A, which is the first one. Close your parenthesis. The last column is our answers, which says X is 8, Y is 6, and Z is 10. So if you took these values and plugged them back into all three equations, they'd better work. Now you're ready to complete this section of homework on My Math Lab. Once you have taken notes on each section and successfully completed each homework, you're ready to take the Module 9 quiz.